Welcome to Educator.com. In today's lesson, we're going to be talking about solving equations. Recall that verbal expressions can be translated into algebraic expressions and vice versa. So you can go from verbal expressions to algebraic and from algebraic back to verbal. For example, if I were given a sentence, a verbal expression such as the sum of two numbers is equal to 7. I could translate that into an algebraic expression. And the technique is to first assign variables. So I'm looking and I see that I have two numbers. And they don't tell me what the numbers are. So I need to assign variables. And I'm going to assign x and y. This is actually an equation, not just an expression. So if I see that I have an equal sign, like this is equal, I note where that is because that's going to divide it into the left and right sides of the equation. So I have an equal sign. I'm going to first deal with one side of the equation. And it says the sum of two numbers. So sum means adding. And my two numbers I'm going to call x and y is equal to 7. And then double check. The sum of two numbers, so x plus y, that works out, is equal to, I have that taken care of, 7. Or another example. A number is 5 less than the square of another number. And you need to be careful with this is less than, because it's easy to get that backwards. So first I notice that I have two numbers. I have a number and another number. Once again, I'm going to use x for one of the numbers, and for the other number I'm going to use y. So x and y are my variables. Now, it says a number is. So I have is, that tells me where the equal sign is. So left side of the equation is just a number. With 5 less than or something less than, the temptation is sometimes to say 5 minus. But that's not correct. What this is saying is look at what comes after the square of another number and subtract 5 from that. So a number is, and then 5 less than, what is it 5 less than? Well, the square of another number. I'm calling my other number y. So y squared minus 5, not 5 minus y squared. So checking it, a number, x, is equals 5 less than the square of another number. So y squared minus 5. And later on in the examples, we'll also see a situation where we're given an algebraic expression and asked to translate it into a verbal expression. As you're solving equations, you need to keep in mind the properties of equality that you've used previously, but it's good to review. So the first property is the reflexive property. The reflexive property states that for every real number a is equal to a. So number is equal to itself. The symmetric property states that for all real numbers, if a equals b, then b equals a. So I can switch the left and right sides of the equation and I'm not going to change anything fundamental. So that's the reflexive and symmetric property. Another property is the transitive property. The transitive property states that if a equals b, so if a equals b and b equals c, then a equals c. Think of it this way. If a actually was 5, so let a equal 5. Well, if I told you that a equals b, then the only way it's going to equal b is if b is also 5. So b must be 5. And then if I went on and said, okay, well, b equals c, if that's 5, then c must also be 5. So I go back, if a, then 5 equals 5, or a equals c. It just follows through. Okay, that is the first three properties discussed up here, but equality also satisfies the addition, subtraction, multiplication, and division properties. And these are properties that you've used before in Algebra 1. And again, you can review these in detail in the Algebra 1 lessons. To refresh them here, the addition principle says that if the same number is added to both sides of the equation, the resulting equation is true. For example, if I have x minus 5 equals 10, and I want to solve for x, the way I'm going to do that is I'm going to add 5 to both sides. And these 5's cancel out. That'll give me x equals 15. So I am not, the resulting equation, after I add 5, if I add it to both sides, this equation is also true. The subtraction principle is the same. Same idea that if I have an equation, x plus 3 equals 5, I can subtract 3 from both sides. I can subtract it, the same number from both sides, and the resulting equation is also true. Multiplication principle. Again, this is something you've used before to solve equations, and it states that if the same number is multiplied by both sides of the equation, the resulting equation is true. So I might have x over 2 equals 12. To solve that, I need to multiply both sides by 2, and that is allowable. Division, same idea. In this case, I may have 4x equals 6. To solve that, I'm going to divide both sides by 4. So the important thing is if you do something to one side, you need to do the same thing to the other side of the equation. Okay, knowing those properties and the properties of real numbers, so the properties of equality and the properties of real numbers, you can solve equations. And we're going to use that frequently, these properties, even if you don't always know them by name, you know how to do them, and you're going to be applying them throughout the course. So, for example, if I have 19 equals 3x plus 4, since usually we have the variable on the left, I can apply the symmetric property and just change this to 3x plus 4 equals 19. So that's the symmetric property that allows me to flip around the two sides of the equation. Next, I need to isolate x, so I'm going to subtract 4 from both sides. And that utilizes the subtraction property, which is going to give me subtracting 4 from both sides. I get 3x, the 4's cancel out, and I get 3x equals 15. Well, now I need to isolate x with one last step, and I'm going to do that by using the division property. If I divide both sides by 3, I'm using the division property, and that's going to give me, the 3's will cancel out, and I'll get x equals 5. So by applying those principles, I was able to solve this simple equation. Sometimes in algebra, you'll be asked to solve for a variable. So these properties can be used to solve a formula for a variable. I may be given a formula such as 4x minus 2y plus z equals 8. And I might be asked to solve for z. So what I'm going to do is I'm going to solve for z in terms of x and y. So while I may not figure out the actual numerical value of z, I can solve for it, I can isolate it, and solve for it in terms of the other variables. So again, I'm going to apply these same principles. So first, I'm going to use the subtraction principle. And I can start out by subtracting 4x from both sides. So that's going to give me, these 4x's will cancel out, negative 2y plus z equals 8 minus 4x. Now I need to add 2y to both sides. Because I had I had negative 2y. So then I'm going to add 2y to both sides so that my 2y's cancel out to give me z equals 8 minus 4x plus 2y. And we usually write this so that the x's, then the y in alphabetical order, and then the constant. So z equals negative 4x plus 2y plus 8. This is solving for z in terms of x and y. First example, write an algebraic expression for the sum of 3 times the cube of one number and twice the square of another number. Okay. Starting out and figuring out how many variables I have. The sum of 3 times the cube of one number and twice the square of another number. X and y. I'm going to assign those as my variables because I have 2 variables. And there's no equal sign. This is an expression, not an equation. So I don't have an equal sign in it. And it says the sum. So I'm doing addition. The sum of 3 times the cube of one number. So that's 3x cubed. And, so that tells me that's where the addition goes, twice the square of another number. So here's the other number, twice the square of the other number. So checking that, the sum of 3 times the cube of one number, so 3x cubed, and, so that's plus, twice, so 2 times the square of another number. So it's y squared, 2y squared. Next, we're asked to do the opposite, which is to write a verbal expression for this algebraic expression. Okay, so looking at what I have, here first I have the difference of 2 squares, and I'm also looking and seeing that I have 2 variables. So the difference of the square of a number, so x I'm just calling a number, so the difference of the square of a number and the square of another number, that's my y squared. Next I have an equal sign, so is equal to. The sum of the square okay, so we have sum, we're adding. So the sum of the square, and I want to make it clear that we're talking about the same number here and here. So I'm going to say the square of the first number and, okay, I'm adding again 3 times, multiplying 3 times x times y, so 3 times the product of my first number and my second number. The first number and the second number plus the square of the second number. Okay, so this was quite long, but you can check it. The difference of the square of a number and the square of another number, I have that right here, is equal to, there's my equal sign, the sum, so it's sum, of the square of the first number and 3 times the product of the first number and the second number plus the square of the second number. So pretty long, but we got everything covered clearly. Third example is to solve, and we can use the properties we discussed today in order to solve this. So first, I'm going to need to get rid of these parentheses, and I can do that by using the distributive property. So negative 2 times x gives me negative 2x plus negative 2 times negative 8 minus, actually let's do plus negative 3 times 9 plus negative 3 times negative 2x equals 4 times 2x plus 4 times negative 9. So just checking, I have negative 2x plus negative 2 times negative 8 plus negative 3 times 9 plus negative 3 times negative 2x equals 4 times 2x plus 4 times negative 9. So multiplying that out, everything out to simplify, negative 2x, and then negative 2 times negative 8 gives me positive 16. And then I have negative 3 times 9, so that's actually a negative, so it's negative 27. Negative 3 times negative 2x, that's positive 6x, equals 4 times 2x is 8x, 4 times negative 9 is negative 36. The next step is to combine like terms. And I have negative 2x and 6x. Those can be combined. That's going to give me 4x. I have constants. I have 16 minus 27. That's going to give me negative 11. Can't really do anything further with that right side. Now that I'm this far, what I want to do is isolate the x, isolate the variable. So I can do that by using my addition property. I'm going to add 11 to both sides. 11's cancel out. That's going to leave me with 4x equals 8x. And negative 36 plus 11 is negative 25. Next, I'm going to subtract 8x from both sides. Again, trying to get like terms together and isolate the x. 4x minus 8x is going to give me negative 4x equals, these cancel, so it's negative 25. Now I'm going to divide both sides by negative 4 to get x equals negative 25 over negative 4. And a negative is a positive, so x equals 25 over 4. I can either leave it like that or I can go on and say this equals 6 1/4. So again, starting out, getting rid of the parentheses by using the distributive property and carefully multiplying out each section. Got me to here. Adding like terms to get to this step. Then isolating the x through using the addition property, the subtraction property, and the division property to get x equals 6 1/4. Okay, in this example, we're asked to solve for h, and we're given, this is actually the surface area of a cylinder. So the surface area of a cylinder equals 2 pi times the radius times the height plus 2 pi r squared. So I need to solve for h in terms of these other variables. And I'm going to start out by using the symmetric property to rewrite this with the h on the left. So I'm going to rewrite this as 2 pi rh plus 2 pi r squared equals s. To get the h by itself, I can start out by subtracting 2 pi r squared from both sides. Okay, once I've done that, then this is going to be gone from this side, and I'll have 2 pi r h. So 2 pi rh equals s minus 2 pi r squared. In order to get the h by itself, I need to divide both sides by 2 pi r. 2 pi r will cancel out, leaving h isolated on the left and s minus 2 pi r squared, all divided by 2 pi r. And you really can't go any farther with this. So started out by rewriting this with the value of the h, which we're trying to isolate on the left, using the subtraction property and the division property to isolate the h. That concludes this session of Educator.com, and I'll see you next lesson.